So what's the shape of the graph? Parabola. So negative in the front, what does that mean? Reflection going downward. -4 inside your square. Right 4. And +3 after the square, the lonely 3. Up 3. So on the same xy plane, first is supposed to draw the original x square without any transformation at the origin, and then you go reflection, goes 1 right, 2 right, 3 right, 4 right, 1 up, 2 up, 3 up here, and you draw the new graph. In this transformation, you don't have to have the exact x-intercept. As long as I see the new vertex, it's fine. How you walk from origin to the new transformation, if you show that, you're fine. Question. So you're going to see a transformation question in the exam. It may not be a square, it may be a cubic function. So if you have a cubic function, let me also draw the cubic function here, just in case. Y equals negative x minus 4q plus 3. It's same transformation. The original one you draw at the origin. It's x cubed without any transformation. And you go reflection. 1, 2, 3, 4. 1, 2, 3 here. And then you draw a reflection.
What if I don't trace the QQ side with the dotted line trace?
As long as you have at least x cubed, you're fine at the origin. You can draw either x cubed or you can draw negative x cubed. This is negative x cubed. One of them you can assume is the original one.
I don't put a dotted line. I didn't put it.
This one, right?
Yeah.
You're fine because if you show a positive x cubed, it's the original one. So some people think, well, I want to say my negative x cubed is the original one. If you say that, no problem. As long as you have either positive one or negative one at the origin, if you have something at the origin, then you are fine. Okay, question. No? Problem. We have a square function, and I also showed you the cubic function. So we are doing 3.6. In our last class, we did evaluating function. So you have a function, they give you x value, you substitute with all the x, you substitute all the x with the value, and then simplify. So sometimes it could be a number, sometimes it couldn't be a number, it will be just variables. So it doesn't matter what they give you. Main idea is every x becomes whatever they give you, and then you have to rearrange everything. Today we're going to say the same thing, but with a new types of function. It's called absolute value function. And you already know the absolute value function has a V shape, right? Without any transformation. So if you draw, this is absolute value of x. What do you observe about the y values? If I give you x is -2, what's the y value? Positive or negative? Positive. If I tell you substitute x with 0, then what's the y value? Positive. If I say x is positive 3, what's the y value? Positive or negative? Positive. So it doesn't matter what you substitute x with, y always positive. So absolute value function will never going to give you any negative results. It will always give you a positive result when you take out your absolute value. That's because function-wise, it's never negative without transformation. And in real life, absolute value represents the distance from 0. So if they ask you what is absolute value of 2, it means from 0, how many units you are going to get to. What's the distance between 0 to 2? It's 2. So we get 2. Similarly, if they tell you what's the distance between 0 to negative 2, still 2. So anytime you pull out your absolute value, you're always supposed to have a positive result. You can never have a negative result when you pull out absolute value for a number. For variable, it's different case. For a number, it's always positive. So we are going to do the exact same things we did before. F of x is absolute value of x minus 2. They want us to first find f of negative 2. It means every x you see in your function, substitute with negative 2. And then simplify. So what is negative 2 minus 2? Negative 4. So inside is negative 4. If you pull out absolute value, it becomes positive 4. Basically, it means how much is the distance from 0 to negative 4. So you tell them the distance is 4 units. Next, they want us to substitute x with 0. So what is 0 minus 2? Negative 2. And the result is positive 2. So in the exam, you must pull out the absolute value. If you stop at absolute value of negative 2, you're going to lose points because you didn't give me the final answer. You just gave me half answer. So you must always take out your absolute value and give us the distance from 0 to that number. Lastly, they want us to substitute our x with 7. So what do we get this time? 5. 7 minus 3 is 5, and 5 is already positive. Question?
Why is it 7? So negative 2 or 2?
Because they said find f of negative 2, f of 0, and f of 7. Here. For this function, find the 3 y values for the 3 x values given. The first we substitute x with negative 2, the next x is 0, and the last x is 7. So this is part A, this is part B, and this is part C. Any other question? Okay. Now you're going to do something interesting. If you understand, it's very easy. If you don't understand, it's complicated. But I don't understand why people think it's complicated. Why students don't understand or what students don't understand, that I don't understand. So that's why, since I don't understand what they don't understand, I can't help them to understand what they're supposed to understand. See? Okay, domain and range. Domain represent what? X values. So you look at the x-axis and see what x values you have in your function. Based on the x values you have, we write domain from the smallest x value on the left to the largest x value on the right. That's what you're going to do. Observe your function. If you're given a graph, You observe your graph and see what is the smallest x value you have in your graph until what's the largest x value you have. And then put them in interval notation with a comma between the two numbers. Same thing for y. You look at on the y-axis for a range, and you see in your graph what is the smallest y value until what is the largest y value. If your graph is continuous, you just take the smallest y value to the largest y value, put in an interval notation, and that's the range. That's all you have to do. No math is needed. You just observe the x-axis for x values, y-axis for the y values. Is it hard? No, right? It sounds easy. So let's do some example and tell me if you don't understand why the domain is that and why the range is that. Is it a continuous graph or is it a piece of the graph? Continuous. So this line going on forever and ever, this line going on forever and ever and ever. So if you observe the x-axis, what is the smallest x value you see in your graph? -2 is here.
Oh, so negative infinity. Smallest x value? That's fine.
5 is here. Is it the smallest x?
That's nice. Yeah. Yes.
So this is 5, right? Here, what is the x value?
Let's see, 0.
And here, what's the x value?
It's 1. -1.
-2. And if you keep going up, like here, what's the x value?
-2.
Here, -7, but this line going on and on and forever. So what is the smallest x value we have?
0.
0 is in the middle.
So infinity, like this?
Infinity, but on the negative side. Negative infinity. So what you can do is you can extend your x-axis until negative infinity, and you can extend your x-axis on the right side until positive infinity. It means you don't know what is on the left. It's until negative infinity. My infinity looks like 8. It's not 8. Okay, it's infinity. Infinity. So on the left side, you have negative infinity. On the right side, you have positive infinity. Since the graph is going on forever on the left side, so what is the smallest x value we have? Negative infinity. So our domain has the smallest x value, negative infinity, and negative infinity will get a parenthesis because we don't know what is exactly negative infinity. When you don't know exact number or when you don't see exact number in the graph, you have to put a parenthesis. If you see something visible, it's a bracket. And if you don't see anything, if you be whole or it's continuous forever, then it's supposed to be infinity. So parenthesis. So our smallest x value on the left side is negative infinity. Now this line is going on forever and ever and ever on the right side. So what is the largest x value we can have in your graph? Positive infinity. And again, it's supposed to get a parenthesis because we don't see that. Now, who is confused? If you're confused, please tell me so that I can understand what's wrong.
I was going to ask, what's a non-infinite graph? Can you show us like doesn't have an error?
Even if it doesn't have an error, as long as you have a stopping point. For example, here, you have a stopping point. So if you have a stopping point, it's a limited graph, it's a piece of graph. If you don't have a stopping point, the line is going on forever. Without even error, it's going on forever. We are going to some example. For example, this graph. Here, this piece is not continuous. Sorry, this piece is not continuous. So this is limited because that's stopping point. This is also limited because it's continuous. So when you have something to stop at, then it's not continuous forever. But this graph, the left one, doesn't have a stopping point for x, so it's going on forever and ever and ever, like a butterfly. Now the range is what? Y's, right? Now if you observe the y-axis, And if you look at the graph, what is the smallest y value you see? This is the smallest point in the graph, and the y value here is 3. So we do see a smallest number for the y. It's 3. And since we see that, it's a closed circle, we can see it. So it has to get a bracket. Bracket means the number you have here, it exists in the graph. And parenthesis means the number which is next to that, it doesn't exist in the graph. We don't see it. Okay, so smallest number, comma, to the largest y value. Here our y value is 8, but here our y value is 10, and the line is going on forever and ever. Positive infinity. Because here this line is going on forever to the positive side. Again, we can see the infinity in the graph. Parenthesis. Anybody is lost yet? Okay, sure. Positive. Okay. The next one. Domain. Again, what is domain? X or Y? X values. So by observing the graph, what is the smallest X value you see in a graph? X value 3 is here. X value 0 is here. X value negative 4 is here. X value negative 8 is here. X value negative 12 is here. So since the line is going on forever, 150 the smallest X value.
Or negative infinity.
So when you don't understand, you look at the graph and pick X value, like you pick 0. So when you pick 0, 0 is here. But is the 0 only the smallest number? Don't you have any part after 0? You have it. So the line going on forever on the left side. So it has to be infinity with the negative side. The negative infinity. Now this line is going on forever and ever and ever. So what is the largest X value we'll find in the graph? Positive infinity. Emails. Okay, any question about domain? No? Now the interesting one is range. What is range again? X or Y? Y. So what is the smallest Y value you see in this graph? 3. What is the largest Y value you see in the graph? 3. So you have only one Y value. So for only one number, we don't use bracket or parentheses. Do you remember what we use? Curly bracket. When it's a single number. I think we talked about this before. I feel like we did. We did? No, we with the range and the like with the inputs and outputs. Why do you use single numbers? Like we did the example 1, 2, 3, 4, and like that. Okay, so here you have a single number, not a set of numbers. When it is single number, it's a curly bracket. But good, you understood the concept. This is amazing. And now something that is not continuous forever. So when you don't have a continuous piece, you look at each piece individually and find their range and domain individually. And then if you see in the domain or range, there is no gap in their journey, then you combine them together. But if there is a gap of numbers, like the numbers you don't see between any two numbers, then you cannot put them together. So let's start with domain. Our first piece is on the left here. And this piece is going on forever on the left side. So for this piece, what is the smallest x value we can have? 0 is here.
0 is there, sorry.
0 is here. Actually, the smallest x value.
Infinite,
Negative infinity. Because the line is going on forever. So this piece has smallest value negative infinity. And it keeps going on and on until here. So what's the x value here? 0. But do you see any y value for this x value? Really? It has a hole. So do you see any y value here? No, because the graph stopped before it reached 4. So it goes to 4, but it cannot touch 4. There's a hole there.
So if it goes like.
So if it has a hole.
Like 1 unit to the right, then it would have been 4.
If
it was extended like 1.
Continuously, then yes. But since it stopped there because there is a hole, so it cannot pass the hole. So it stopped at 4 and it could not use 4. So it's a parenthesis. It goes up to 4, but it doesn't use 4. There is a hole. So it's like it's walking, and it's no, like this thing. Walking, and suddenly, it's a hole there. I cannot pass it. So it goes up to 4, but it doesn't use 4. Since it doesn't use 4, so you have to put parentheses. Because we don't see the y value 4, we see a hole at 4. So its journey started from negative infinity to 4, and it stopped.
But you're saying it's not 4, but I see it up there. Like
you see 4, but do you see the y value there?
Isn't the 4 up there like the y value, or is it the?
I see a hole there. Do you see the hole there? Do you see the hole?
Yeah, I see the circle.
So when you have a hole, it's not a circle, it's a hole.
Oh, yeah.
It means it's empty. So do you have any y value there? It's supposed to be 4.
No,
but do you see it? No, you see a hole. You see empty. You see empty hole. It's not like empty hole because this is closed. It exists. We see a number inside.
Yes.
But here we don't see a number because it's an open circle. It's an empty circle. It doesn't have anything inside. It's supposed to be 4, but it's not 4 because it's empty inside. However, once it goes there, then we have a second piece. In this second piece, what is the smallest x value? 0. So this piece, let me highlight a different color here. This has domain 0. And when x is 0, do you have any y value there? Yes. Yes, because it's closed. So something is inside there. So we have a y value there. So we have a bracket. So on the left journey, we don't see a y value because it's an empty circle. But when it starts its next journey, it has a y value. So you put a bracket instead of parentheses. And now in this journey, what is the largest x value we see? 1. Here. And do you see any y value at 1?
Yes.
Yes, because this is closed. Something is there. So that little journey, it starts from 0, stops at 1. It's only 1 unit. So it stopped again. And then it jumped and start new journey here. And it has a hole here. So here. What is the x value, the smallest x value in this journey? X value. At this point, what is your x value? 1. So you start from 1, but do you have any y value at 1? So what's the boundary? Parentheses or bracket? Parentheses. Because there is no y value there. It started its journey, but unfortunately, it started lonely, alone. So 1. And then this journey is going on forever and ever and ever and ever. So what's the smallest x value we have? Positive infinity. Oops. And infinity always get parentheses because we don't see. So it has 3 portions of its journey, and now let's look at them together. So if you look at the x-axis, assume this is x-axis. It started its journey from negative infinity. It goes until 4. Sorry, it's not 4. Why did it at 4? Come on, it's 0. My bad.
That was my point.
Actually,
You guys understand?
Thank you. What did you do?
I was gonna cry, man. All right.
Sorry about that.
No worries.
Please do it. It started its journey from negative infinity, goes to 0, but when it reached 0, it got lonely because it became empty, right? And now it started its journey again. So let me change the color. Exactly from 0, and then it goes until 1, right? Negative infinity to 0, and then exactly 0 to 1. So for 0 and 1, it's not lonely anymore. It has its partner y. And then when it reached at 1, it goes forever on the positive infinity. So do you see any gap in its journey? It started from negative infinity. Even they stopped twice, but they still have some y values. Not in a single journey, but in the next journey, they have their y values. So do you see any gap from negative infinity to positive infinity? Is there any gap in this journey? It's in front of you guys. Do you see any gap here? Where? Here? So in the first journey, it has a gap, but it started exactly from the same spot. So does it have a gap here? It stopped here, but start at the same position. So did it skip any number? No, it didn't. It did not skip anything, right? It stopped at 0, but started again from 0 and went to 1. Stopped, but then started again from 1 and then went forever. So is there any number gap here? No. So what is its total journey? The final, the total amount of journey. Negative infinity till positive infinity. Even though it stopped 3 places, but at the end it covered the entire x-axis. It did not have any gap in the x-axis anywhere.
But you can't rate it.
We can combine them because there is no gap at the end.
So what was the point of writing all 3?
To show us that they have a different pieces. And then you can combine the different pieces. So our final domain is actually from negative to positive infinity. So in his entire lifetime, it stopped twice, but it didn't stop its journey from negative to positive infinity. So it covered the entire x-axis.
Why do you think translate that instead of writing all 3?
If it's possible.
And that's right.
Now look at the y. Does y cover the entire y-axis? So let's take a look at the range. And let me change the color for each. For the first portion, what is your range? The y value. Y value 4. And it's a single number, so it neither get parentheses nor get bracket. It's the curly bracket. Y value, the range. So you have three pieces. You have to find their individual domain and range. So we did the domain first. And if you get out, we just wasted our time. We covered the entire number line, entire x-axis. Now we have to decide the same scenario for y. So on the left side, the first piece, they use only one y value for. So even though you don't see the y value for x0, but it exists everywhere else. Now in the middle piece, what is the smallest y value in this middle piece? 0. And what's the largest y value? Positive 3. Do you see the y value at the end? Is there any hole or they are closed circle? Closed circle means the y is there. So you have to get bracket. As long as it's not whole, you always put bracket. So in the middle piece, our y's from 0 to 3. And now in this piece, the last piece, what is the smallest y value you see? Negative infinity, so parentheses. And in this piece, what is the largest y value? Negative 1. But do you have any value for negative 1? No. So it's parentheses. Now, if you look at the range separately, together, we have to start from the smallest one. We have negative infinity to negative 1. So if you look at y this way, negative infinity to negative 1. And then we have from 0 to 3. So it starts from 0 and it went up to 3. And then we have the number 4. So it suddenly have number 4 here. So this is its journey. Starting from negative infinity goes to negative 1. It jumps, goes to 0. I should indicate that. Now from negative 1, it jumped up, goes to 0, and then 0 to 3, it ran. And then from 3, it jumped up and then got stuck. Nowhere to go. So did you cover the entire y-axis? So can you combine them? There is no y value here. There is no y value here. So you cannot combine the y-axis. See, X was smart. It stopped, but they started from the same position. But y is down. It started, it stopped, and they didn't think about, oh, let me start from the same position. It didn't think about that. It skipped a number and then started its journey again. Since it skipped, you cannot combine the two journeys together. So same graph, we can combine the x domain, but we cannot combine the y range. So for y range, you have to write this entire thing. So this is your range, final range, and this is your final domain. Range cannot be combined because they have gap. X can be combined because even though they have gap, but since they started from the same position, at the end, we did not have any gap. Oh yeah. In the final exam, they'll have to give you one of these questions. That's why I wasted, that's why I used almost 10 minutes on this. So anybody has any question? Are you sure? No question from anyone? Great. So if you're lucky, you see the graph. And then you can figure out domain and range. But not always they will give us the graph. Sometimes they'll give us the equation and tell us, hey, Find out the domain and range for the equation. Fortunately, finding domain is easy, but finding range is hard. So you're not going to learn how to find range of an equation. Instead, you're going to learn only the domain, how to find the domain of an equation. Now, domain is they are based on the graph. They have their individual way of finding it. If you have a polynomial graph or if you have an add function, sorry, not add function, add root function, then the graph is continuous forever. So domain is from negative to positive. So you may wonder how this polynomial. Polynomial means we cannot have any variable in the denominator. It cannot have negative power. It cannot have fraction power. Three things. So no variables in the denominator is 1. Then 2 is no negative or fraction power. Yeah. Run it nicely. So if you have no negative power, no fraction power, and there is no variable in the denominator, you may consider this a polynomial. For example, y equals mx plus b. It's a polynomial because x has the power 1. It's positive integer. And also there is no variable in the denominator. Or y equals 100 x to the 99 plus 5 x to the 80. 99 and 80, they are positive integers, and there is no variable in the denominator. It's a polynomial. So every polynomial is continuous, means the graph is continuous forever and ever. So that's why our domain is everything, negative to positive infinity. Add root function, it's like y equals cubic root of x, fifth root of x minus 7. So root means this. The number you see inside the radical, as long as that number is odd, then it has no problem. Cubic root and polynomial, they are the most generous one. They care about no number. They take everything, positive, negative, decimal, zero, everything. We can substitute our x's. It's like water. They take everything with them. Our problems start with radical equation, radical function. If you have square root, means if these numbers inside are not add but even, then there is a problem. One example, y equals square root of x. Another example, y equals square root of, let's say, x minus 5. Or fourth root of that. When you don't see any number having invisible 2, you know that, right? Square root means 2 inside. So see, 2 is an even number, it has a problem. Here is square root, it has a problem. Or another example could be y equals fourth root of x plus 1. So if these numbers are even, you may wonder, what's the problem? First start with square root. What is square root of 4? 2. How do you know? What did you do? How did you figure out? 2 times 2. So basically it means you're multiplying the same number twice and the result will be the inside, right? So fourth root means you're multiplying the same number 4 times and the result will be the inside. So you have to multiply the same thing even many times, right? And the result will be the whatever you have inside your function. For example, fourth root of 16. What is fourth root of 16? So what number if you multiply 4 times 10 into 16? 4 times 4 times 4 times 4 is a big number. It's 2. If you multiply 2 4 times, it's 16. So 4th root of 16 is 2. And what is square root of 16? Square root. You're multiplying same number twice. So you're multiplying the same thing radical many times. Okay. So what is square root of 0? What number if you multiply the same thing twice, you get result 0? 0. So square root of 0 is 0. Square root of positive number is positive. But if I tell you what is the square root of negative 1, what can you tell me? Can you find the same number multiplied twice, turn into negative?
You said what?
Square root of negative 1.
Yeah.
So we are multiplying same thing twice, the result is negative. Is it possible? If I tell you to multiply the same thing 4 times, but the result will be negative. Is it possible? No. So even root has the problem, the inside cannot be negative. It can be 0, it can be positive. But it cannot take anything negative inside. So that's why this function, we cannot put negative 1 here, or negative 2 here, or negative 3 here, or negative 4 here. We cannot put any negative number here. So what is the domain for this function? What is the smallest x value we can plug in for x here? 1 is possible, but can't you substitute anything before 1? 0. Can you substitute anything before 0? What numbers we have before 0? All the negatives. Can you plug in negative? No. So it has to start from 0, and we can substitute 0 because square root of 0 is 0. What is the largest number we can substitute for x? Can you substitute x with 100? What is square root of 100? What is square root of, let's say, 10,000? It exists, right? We don't know, but it exists. What is square root of a million? Still exists. It's a real number. So what is the largest number you can substitute x with? Infinity. Any positive number is fine. Any. It doesn't have any limits. It could be any positive number, but it cannot have any negative number at all. The smallest number possible is 0. So this is true only for when you have x inside. Is this true when you have x minus 5 inside? Can you plug in 0 here? When x is 0, what do you get inside? Negative 5. Can you have negative 5 inside the radical? What if x is 1?
No.
What is 2? 3.
We started at
5.
So you have to start from 5. And when it's exactly 5, can you substitute x with 5? Because 5 minus 5 is 0, and square root of 0 exists. So its journey had to start from 5, not from 4. So not from 0. And then what is the largest number you can substitute? Infinity. So how do you find all of the domain? The only thing is, whatever function you have inside your radical, set that equals to 0 or bigger than 0. So bigger than or equals 0, and then solve for x. It doesn't matter what function they give you inside your radical. It could be a complicated function. It could be easy function. It could be anything. Whatever they give you, take that function, set it bigger than or equals 0, and then solve for x. And see, starting from which x, you get something positive or 0. Clear? Then the last type, rational. Tell me a rational number. What is a rational number? Fraction, 1/2, 2/3, 4/5. Anytime you have a fraction, it's a rational. So 1/2, 1/2. Is it a real number or imaginary number? real number. Negative 1/2. Is it a real number or imaginary number? Real number. 1/3. Real or not real? Real. 1/-5. Real. How about 1/0? 1/0, it means you have one pen, one candy, one whatever, and divide it into 0 pieces. Can you ever do that? Divide anything into 0 pieces? No, so it's not possible. So rational has a problem. We can have anything on the denominator, positive or negative, but it cannot have 0. So what we do is we take the denominator. For example, one of the example is y equals 1/x. Another example is 1/x-5. Let's see. So what number we cannot have on this denominator? 0. But we can have everything else besides 0. So the domain for this one is from -infinity to 0. Because we cannot use 0. And then from 0 to positive infinity. Means from the number line, use everything else, just don't use 0. Anytime we cannot use anything, we have to put parentheses for it. Looks like 1. It's not 1, it's 0. Sorry. Now if you look at this one, it's substitute x is 0 now. When x is 0, what do you get? 0 minus 5 is? And do you know what is 1/-5? Is it a real number or imaginary number? Real. Ah, we can substitute x at 0 here. What number that I cannot substitute?
5.
How do you know? Why?
Because if you do 5 minus 5, then that's 0.
Good. So whatever makes the denominator 0, that is our goal. Not only 0, the final result is to be 0. So what makes the final result 0? We cannot have that number.
Yeah, I was just going to say the negative infinity. 5.
So we know x cannot be 5, but x can be everything else. So domain is -infinity to 5, parentheses, union, 5 to infinity. So basically from -infinity to positive infinity, we are going to use everything, but we cannot just use 5. So you see, that's because it's here denominator cannot be 0. It's not true. The denominator cannot be 0. So whatever denominator they give you, you have to see what makes that denominator to be 0. So what you do is set the denominator equals to not 0, because that's the rule. Denominator cannot be 0, and figure out what x cannot be. Omit that number from the number line, everything else will be in the domain. And these are the 4 types, or mainly 2 types of problem we have here. Now let's do some examples. What 2 problems? 2 or 5, right? What type of function is the first one? Continuous or not continuous? Continuous, this is the line. So what's the domain for a continuous function? So without even they tell us, we know it's a line, and line is always, sorry, this is increasing or decreasing line? Decreasing line. How do you know? Slope is negative. So the line is going on forever. So domain is negative to positive infinity. For a continuous function, they are like water, they take everything with them. They have no problem. They do not discriminate against anything. Then the next one. What type of function is the next one?
What type?
What type? What's the name of this function?
You said
Rational. Be confident, guys. You know the answer. Rational. And for rational, what is our problem?
You do x plus 8 cannot have 0.
So rational has one problem. Denominator cannot be 0. So in this example, our denominator is x plus 8. So x plus 8 cannot be 0. So x cannot be what number? Negative 8. So from the number line, you take negative infinity to positive infinity. But there's only one number you cannot use. You have to break your interval into two pieces. Negative infinity to negative 8. Right. And do you put parentheses or bracket? Parentheses because you cannot use. Anytime you cannot use anything, it's parentheses. And then parentheses negative 8 to positive infinity. So basically from negative to positive infinity, there's only one number you cannot take. And then you take everything here, everything there. So this is why we have to have two separate ones. From negative 3 to negative 8, we are allowed to use all the exponents. You cannot use negative 8. So you have to jump. And then from negative 8 to everything you can use, you cannot use that. So rational means denominator cannot be 0. Not x cannot be 0, okay? X can be anything, but what makes the denominator 0? X cannot be that number. Now the next one, what type of function is this? Square root function. So square root, is it even function, even root or odd root? Even root. So we have even root function. And for even root, what is our condition?
Whatever is inside the root, greater than.
Function inside the root or radical has to be 0 or positive. It can be 0, it's real, or it can be positive. Not x, okay? The function, and then you're going to decide which x fulfill this requirement. So in our case, this is the function we have. So we take 100 minus x, and that function has to be bigger than or equals 0. It can be 0, it can be bigger than 0, but it cannot be negative. So which x values satisfy this condition? How do you solve for x? We can subtract 100, no problem. So we left with negative x and negative 100. And then you can multiply, divide by negative 1. So you get x and 100. Now, before I put something in the middle, let me ask you a question. Which one is bigger, 2 or negative 2? 2. So 2 is bigger than negative 2, right? We all know that. Now, if I multiply everything by negative 1, we get negative 2 here and positive 2 here, right? Negative 1 times 2 is negative 2. Negative 1 times negative 2 is positive 2. So what happens to the inequality? Flips. Anytime you multiply or divide by a negative, you have to flip it in the positive. So you cannot say bigger than anymore. You have to say it's less than or 0. Okay. Multiplying or dividing by a negative means everything. So what is telling us? What is the smallest x value we can have here? 100? 100? Okay, let's see. We have negative infinity, positive infinity, and 100 is somewhere here. So read it. Read. Is smaller than or equals to 100. So this is my 100 on the number line. What numbers do we have that is smaller than 100? On the left side or the right side?
Numbers between 100 and negative infinity.
Here. So what's the smallest x value you can substitute? Negative infinity. So domain negative infinity to 100. When x is 100, what do you get in the equation? 100 minus 100. And what is square root of 0? 0. So it exists, right? So can you use 100 for our x? So what should be the boundary for 100? Bracket. So this is our final answer. So for rational, we can use everything besides a few numbers. For radical, we can use only one side, not the entire number line. Only a side, only a portion of the number line. We are allowed to use it. Okay? Any question? Now the same thing, but we have a different function inside. They look same, but they're completely different function. But we have the same problem, right? Whatever we have inside, that thing cannot be 0. Now, if you want to use logic, what makes this function 0? What number? Which value of x makes this function 0? 10. Definitely 10. So, oops. I'm using logic here, okay? We have negative infinity to positive infinity. So, 10. When x is 10, we have y value 0. Right? And 0 exists. Square root of 0 is 0. But is 10 the only number that makes this function 0? What are other numbers we have that makes this function 0? So there is one more number that makes the function 0. Now we want inside to have only positive, right? Because we know these two make them 0. So you're okay with them. Negative 10, positive 10, you're fine. Now we have 3 intervals. Which of these intervals makes them instead positive? How can you figure that out? Let's say I pick a number here. What number you want to pick? Anything smaller than negative 10? 11? Okay. Let's see. When x is negative 11, what's the y? Negative 11 square minus 100. What is negative 11 square? 121. So we have y equals 121 minus 100. Is it positive or negative? Positive. So can you substitute anything from here? Yes. Anything you substitute from this interval, makes the inside positive. And positive is real, it exists. Only when you have negative, it's not real. Now, let's pick anything in this interval. What number you want to pick? The best number would be what? 0. My favorite number to substitute. When, I should change color. When x is 0, we have y value 0 minus 100, right? What is 0 minus 100? Positive or negative? Negative. So can you have square root of a negative number? So this interval is a bad interval. It gives negative output. Now we check the last one. Any number bigger than 100, sorry, bigger than 10. You can pick positive 11. So your y value will be 11 square minus 100, which is 121 minus 100. Is it positive or negative? Positive. So can you substitute any x value bigger than 10? Yes. You can take any number bigger than 10 and you get the result positive. So what's the domain for this function? Negative infinity until negative 10. Can you use 10, negative 10? We can. And then 10 to infinity. Negative infinity to negative 10. It looks like 8. It's not 8, but it's infinity. So negative infinity to negative 10. We can use 10, but I don't know how to use infinity. And then from 10 to positive infinity. So this domain is 2 piece. It doesn't use the middle piece. On the other hand, the last domain can use only the left side of whatever we have done up with.
What have we been using log?
You can pick any number.
If the answer is 10. Just to check.
You have to pick a number from here to see does it give you positive value or negative value. So you can we pick
Your
11.
answer is the smallest value in the interval. Like 10 is the
10 is the smallest
smallest
one in this
value.
interval.
Yeah.
So you have to pick anything bigger than 10. On the other hand, 10 is the largest number in negative 10. You have to pick anything smaller than that. You can pick negative 100, no problem. Or positive 1000. No. So how do you know when to use this and when to use that? Well, if you have a square inside the square root, you have 2 is number 1. Because square means you're supposed to have two problems. This x doesn't have any square inside the radical. So it has only one problem. When you solve for x, you get only one number. But if you have a square inside the radical, you're supposed to have 2 numbers. Anytime you have more than 1 numbers, you have 2 is the number line to check which interval gives us positive result. Okay? For some reason, people love this. So you may see this type of question in the final. Any question? Comments? Complain? It's a fun time. You are going to do all of these with your peers. I'll give you 5, 10, 15 minutes. Okay? 15 minutes. We did all of them before. So do all of these, and I'll do that. I want all of you to do them, okay? Don't just sit here like this, like statue. Enjoy. You're welcome. Oh, before that, let me take the attendance. Before I forget. So today is lecture 4. 1, 2, 3, 4, 9, 5. Ashley, Jelisa, sorry. Jelisa, Michael, Lady, Lola, Jonathan, Diaz, Reina, Ali went to the restroom. Denisa, where? No. Denisa Farah, Samantha, Nicole, huh? Oh, okay, thank you. So yeah, could be Nicole, Andy, Priya, Caitlin, Andrew, George, Mariana, Daniel, Fatumata, Asmain, Khalid, no. Shuwing, Chloe, Lee, Ethan or Tan? Ethan, yeah, right? Kathleen, Brennan, Raim, R-Y-E, Raim, right? Right. Shahana, Shah or Sa, I forgot. Sahana, okay. Leonardo, sorry. I have Leandra and Leonardo, so I have to read. Is it Leonardo or Leandra? Because they look so, all the letters are same, just the arrangement is different. Brian. I have two Brian? Oh yeah, two Brian. Brian Munoz and Brian V. Cool, two Brians. Gian, right? Gian. Alex. Anastasia. Denisa? No? Okay, guys, enjoy your math. Brennan, right? No fun. We want to write this in our last class, and we want to write this too. So with the neighbors, enjoy doing them.
But this is from last. Yeah.
I don't know if I did it right. The way I did it is like like gravel.
Uh-huh.
So we just try to execute this type of thing. And get y equal negative x. That's gonna be a function.
So that way, okay. So basically just get y. Like
By the time,
so like
because maybe it's y equals eight,
uh-huh.
because it's just gonna be its own. So it's
Maybe I can know.
Okay.
It would be turned on attendance sheet. Yeah, I came like 10 minutes late.
She should
No,
do it.
you did it. Right now?
Yeah, like coach.
I probably just called out names.
She probably marked you, sure.
Oh, she knows mine. Yeah. I thought it was like paper. Someone had paper.
No, you're just calling out.
Oh, okay.
Two more minutes, okay? For what? Without using calculator.
It's 18 times -2.
That's why you shortcut. I taught you shortcut. Without multiplication, what can you do? Cancellation.
Oh, so 18 and 3, right?
3? What comes first? Parenthesis what?
Negative.
Uh-huh. Really? What your x has?
Oh, wait, I asked you the exponent. -2 would be squared.
Negative?
4/6. I'm not even.
6?
No.
See?
But
Mental math.
4/9.
Mhm. So if we cancel 18 and 9, what happens?
Minus
See, there is no more fraction now.
because it was 3 times 2/3. So it would be shortcut here 3.6 by 2 times 2 minus 4 negative 2 minus
So the quiz for your next class. One of these.
yeah. Okay. Let's
Okay?
so this will be the okay.
For your next class, the quiz will be based on this.
Wait.
Okay, volunteer for C. Any volunteer for C? Go ahead, Daniel, right? 28 minus 7x squared cannot equal 0. Add. Add 7x squared. So 28 cannot be 7x squared. Divide by 7. So x squared cannot be 4. So x cannot be which numbers? Plus 2 and also minus 2. So there are two numbers you cannot substitute. So if you want to visualize this from negative to positive infinity, you can substitute everything. You cannot just substitute negative 2 and positive 2. So everything before that, between that, after that. So how are you going to write this in table notation? Any volunteer for the interval notation? when x is -2, if denominator is 28 minus 7 times -2 square, so 28 minus 7 times 4, 28 minus 28, which is, so can you have 0 in the denominator? So can you substitute x with -2? So we cannot substitute, what to use for the boundary? Parenthesis. Because we cannot use -2. Good. The next one. -2, because we have everything in between them. So the first piece is here, before -2, but you have between -2 to +2. So -2 to +2, and can you substitute x with +2? That makes the denominator 0. We cannot. So that was the middle piece. And at the last piece, union. What's the last piece? Here. 2 to what? Infinity. And again, you cannot use 2. So there are 3 pieces because we have 2 numbers that you cannot allow to use. Any question? Okay. I will. Okay. Then we have a D. Y equals square root of x squared minus 1. Volunteer? X squared minus 1 greater than or equals 0. X squared greater than or equal to 1. Now you have a problem. When it is the square root, it cannot keep your mouth. The mouth of your inequality, it's not always true. When it is the square root, it's not always true. So you can say x squared equals 1. It makes sense, x squared equals 1, but you cannot say greater than, x equals +1 and -1. It's true, x is equal positive and -1. But which part is bigger? To determine that, you have to use number line. You cannot say x squared is bigger than 1. That means x is bigger than positive or -1. This is false. Okay, this is true, but the bigger than symbol, it's false. That's why you have to test the correct one. So number line, -1 and +1. These two are allowed. They make the y 0. So definitely going to take them. And now what you're looking for? The interval which gives what? Something positive. So let's see which of these intervals gives us positive outcome. So you have to test all of them. So start with the very left interval. Anything smaller than -1. What number you want to pick? -3, no problem. So what do you get? Y equals square root of -3 square minus 1. What is -3 square? 9. And what is 9 minus 1? Is it a real number? Yes. So we can substitute all the numbers from this interval. It's a good interval. And then you check the next one. What number you have in the middle? 0. So y equals 0 square minus 1. What is 0 square minus 1? -1. Can you have negative number inside the radical? So this is a bad interval. And since the left one work, right one also work because they are the same interval, just the signs are different. You took -3 here, take +3 here, you get the same result. So this one also work. So if you test 2 of them, you know the third one. So what's the domain? -infinity to -1. It's bracket because when it's -1, y is 0, allowed. And then the last interval, 1. Can you use x equals 1? Yes, because that gives us y equals 0, which is true, which is real. Infinity. So this is the intervals. The other page I went over with my morning class. So watch the recording for my morning class for the left page. And now homework. Let me tell you what will be your homework. Homework for 9/9/25, which is next Tuesday midnight. You have 8.1, 8.2, 3.6. 3 homework, but there is only 1 quiz. Only 1 quiz online, which is 8.1 and 8.2.
So, since the 8.1 was due next Tuesday, we have chapters like 8.2, 3.6, and that.
And in class, you're going to take a quiz based on the domain.
Yes.
Have a good weekend. Enjoy your homework. It was, but then some people didn't get the access yet. So for them, I extended again for 1 more week. If you already done that, you're fine. But if you didn't do that,
has to do with this.
3.2, 3.6,
3.6, I'm sorry, has to do with
domain
quiz that
range.
we should have taken. It would have been the only quiz.
No,
It would have been the only quiz
3.6,
next Tuesday.
3.6 connects with 5.1.
And it would have been the only quiz we would take next Tuesday if we weren't late. Awesome. Thank you. Thank you so much.
No problem.
Send Imam Baruch when you went to
Thank
Imam Baruch. No, that means,
you. No,
no.
I know Baraka, but
This Friday, it's called Juma.
uh-huh.
Mubarakah, like blessed Juma. That's what Arab, like in Arabic,
Oh,
they say.
so what did you
After
say?
prayer, after they pray, they say Juma Mubarakah.
Oh, Mubarak. I thought you only said Baraka. So I was like,
No.
I heard Baraka, but I didn't hear the word.
No
Yes,
worries, no
Juma
worries.
Baraka.
There's a prayer room, right?
I know, but I don't want to
On the
go
third floor.
there.
I'm saying for me, there is one on the third
Third
floor.
floor.
I heard. Thank you.
So you can go there.
Inshallah, yeah, I'm going to go.
Mm-hmm.
Yalla, salam.
Wa alaikum assalam wa rahmatullahi wa barakatuh.
What did you do for the final exam?